Hello, good morning. This is Naz from NB Network Lessons. Hope you guys are doing okay. My today's topic is differentiation formulas. This is calculus lesson number 4. Today we're going to talk about the formulas which are used to solve calculus problems, especially using derivative. Okay, so let's look at some formulas. So first thing is f prime, as I explained you in my last lecture. This prime right here means it's a derivative. Okay, so if you want to take a derivative of a function of x, you can write this as df over dx. And let me just refresh your memory. So if you've got y-axis and you've got x-axis, all right, so basically, essentially, if you have a function of x, let's say you have a function of x is equal to x squared, okay? So you are basically, and your function of x is right here, function of x. So basically, your graph is going to look something like this, like a parabola shape, all right? So what this means is that the rate of change of function of x with respect to x, how this graph right here, the parabola right here, is changing with respect to x. So that was like a refresher, quick refresher. Now let's get back to the formulas. Okay, so the first formula is number 1, d over dx, derivative of a constant. Constant can be 1, 2, 3, 4 or any number, is 0. Why? Because when we draw d of x, and this is with respect to x, constant is a straight line, okay? Always, constant is a straight line. And as I explained you in my last lecture, slope of a straight line is 0, okay? Number 2, derivative of constant times function of x can be written as constant times df over dx, okay? And I can give you an example of that. So say for example you have let's see, function of x is equal to 9x, okay? All right, so if I take derivative of this, f prime of this right here, what will you get? As you already know, you will get 9 times x of prime. Okay, you can write this like that also. Let's look at number 3, d over dx into x raised to the power minus n. Okay, you can write this as, you can bring this n, which is the exponent on the left hand side, times x raised to the power of n minus 1. Okay, so let me give you an example of that. Let's say you have a function of x is equal to x cubed. Okay, so what would be the f prime or derivative of this? So derivative of this, f prime x would be 3, I'm bringing this 3 right here, times x 3 minus 1, okay? So this is, answer is 3x squared. All right, I just applied this formula. What I did was that I brought the n, which in this case was 3 right here, and then x raised to power 3 minus 1. So that's it. Number 4, what we have is, if you have a function like this, f plus g prime, you can write that separately, f prime plus g prime. Same thing, if you have f minus g, the whole thing, you want to take derivative, you can write them separately as f prime minus g prime. All right, so let me give you an example of this. Let's say you have g of x, all right, is equal to 2x raised to the power 5. Okay? And you've been asked to take derivative of g of x. So how would you do that? Okay? Same thing. Bring this 5 right here. So it's going to be 5 times 2 raised to the power x, 5 minus 1, applying this formula. So then the answer would be 10x4. Alright? And then lastly, number 6 is, what if you have two functions and they're divided by each other? F of x over g of x. What you could do is, and in your calculus books, you will see the derivation also, how they came to this. But in TikTok, as you know, I can't really do lessons longer than 10 minutes, and that might take a long time. But you just have to memorize function of x over function of g of x is going to be g times f prime minus f times g prime all over g squared. Okay? So you have to remember that. That's all I wanted to discuss in this lecture. I think we're moving along pretty smooth. We will get to some real calculus problems also. And then I'm going to do back and forth on AC circuit analysis also. Like I mentioned, you do need to understand calculus in order to understand AC circuit analysis. Well, thank you so much for watching. I really appreciate that. If you like the contents, please share as much as you can and go ahead and give me a like. Thanks.